Okay, this is another vector basics video in which I'll be going through magnitude of vectors and after that unit vectors. So the magnitude of a vector is the length of the line that the vector makes on a graph. So the vector v that equals 3 and 4, if we were to plot that on our graph, go 3 and 4, and the magnitude of the vector, which the notation is denoted by two vertical lines on either side of the vector. From Pythagorean theorem, we know that the magnitude of the hypotenuse is given as our x component squared plus our y component squared, all under a square root. Or if you want to go to Pythagorean theorem specifically, the hypotenuse squared is equal to the other two sides squared and then added together. So in this case, the magnitude of our vector v is square root of 9 plus 16, which is root 25, which equals 5. So the magnitude of our vector v is 5, which is the length of the vector. Unit vectors. The unit vector is denoted by a hat on top of the vector. So the unit vector v is parallel to vector v, which means it lies along the same line. However, a unit vector has a magnitude of 1. Now, in order to work out a unit vector of any vector, we need to know the magnitude of the vector in question, and then once that is found, we apply that back to the components of the vector and we divide by its magnitude. So the unit vector v is 3 divided by 5 and 4 divided by 5. Now if you were to go through and go back through the process of finding the magnitude of this vector, you'd have 3 on 5 squared plus 4 on 5 squared, all under a square root, which would get us to 9 on 25 plus 16 on 25, which 9 plus 16 is 25, on 25 is 1, and the square root of 1 is 1. I hope that was clear and there wasn't any confusion that may have arisen out of that video. But if you have any questions or comments, please feel free to leave them below. And I will see you in the next video.